Hey guys, and one call, welcome to my channel. So very soon I will be getting rid of these batteries. Not fully getting rid of, they will be moved because you see there is a preparation already taking place, and the mounting plate for the new Deye inverter is already sitting on where is it going to be actually living, with the proper, probably possible addition of the third one. Like, I'm leaving this room for expansion open, just in case. And the new battery pack, for stackable and one vertical right nearby. They'll be sitting over here, and the bus bar box will be sitting right over here over the door. So that will be the equal distance to this battery box. There will be another one, a different one, exactly same like the new one. And from this place, like, this will have the equal distance. Same applies to inverters as well. Okay, some preps are also done with the panels. I have the guys from a local company called Avangard Solar. They are always helping me with this kind of stuff. Like, some smaller things I'm doing on my own, but with the bigger stuff where you're required to go actually really high on the roof, that's something that I'm not doing myself. That's something that are the professionals doing. And well, we have done some preparations. We'll be actually adding panels. This is the eastern slope that is left, and some aluminum rails already put on the lower section of it, and the preparations are already started for the upper section. So altogether 6 and 10 panels will fit over there. Small ones, those that are 1.1 per 1.75 meters in size, like 440 watts. In my case it's 435. And let me show you the difference between the aluminum and zinc connection type. So here are those, they are not fixated, they are not like aligned yet, they are just like put here. Alignment happens next. So first of all you apply this screw spindle, so to say. That's how you do this. And of course you use a specific special tape that prevents leakage at whatever stage, and then additionally the EPDM rubber, and of course, I mean, the locking nut and the positioning nuts for this kind of angle, which you can move side to side in case needed to position properly, and of course you can move it up and down, right? So all your aluminum rail, which is actually, by the way, consists of two pieces, and you actually can position it any desired way. I mean, and once I was DIYing my system that sits on that temporary building over there, I was doing it very differently than this case. I didn't use any exact this kind of angles, or I just used, since there was used a steel zinc rebar profile or rebar, whatever, not a rebar bar, but just a profiled bar, right? And I just you put it on top of this spindle, and that's it. So let me go there and show you how it looks like, so you'll be able to see it. So, and in contrary here, where I have my other smaller power stations, as I call it, an off-grid garage station, as I told you, applied directly, no angles, no plates, just directly through the steel zinc bar. That's how it's done, and no issues with that. I mean, there was a trouble, of course, to align this line properly, to make all those actually bolts be sitting on the line, but you can move them a little bit here and there, and just to apply them to the single line. But overall it managed to be okay, and I will be actually improving this one after the guys are finished with that part. I'll be actually adding 5 panels here, so I will make that one longer, move it a little bit to match, because right now you see the edges don't match, right? So it has some extra 30 centimeters probably. And of course here will fit 1, 2, 3 more, and in this place 2 more panels. So I will add 5 here, and this will be 2 per 8, 2 lines, 2 strings, 8 panels each. That will be a little bit later. So let me show you from above how it looks like and what are they doing. And this is how you do it. Two guys have to be sitting on top, doing their job extremely, and one of them has to be the boss, managing and guiding everybody, what has to be done, where from. And exactly, you cannot do this alone, simply. You cannot do it in double. I think it's always better to do it in triples, so to say. Anyways, this is the second day, and well, literally one more day will be required to actually finish all this. Some cable, some grounding is already prepared. Let me show it to you as well. So the cable itself, like this one will be as a loop, because this is all going to be a single array, and that will go down there finally and inside the place where the inverter is. But the ground, since on top I have it, but here I haven't. So the ground cable they actually added, they put and aligned it to go to my lighting grounding system in this place. So it's hidden right over here, and I mean it will work if it will be needed, once it will be needed. But in general, like to minimize the facade drilling, we actually use like this, the shortest way, and then up using the drainage pipe. That's how it goes. I mean, that's a pretty standard stuff. But yeah, next day the panels will be mounted. Not today. Today, no chance. A little bit of stuff added. Some cable tunnels. How do you call those conduits? But it's not a conduit actually, it's a plastic box where you put the cable into. And I mean, this is the place where the huge bus bars for DC will be actually mounted. Two big ones for a lot of connections, like 14 holes I think, maybe 15 even. But that's for 700 amps. Let me show you how it looks like. It's in preps right now. And that's how this huge bus bar looks like. A nice piece of copper, quite thick, with many holes. Actually 18 of them. Two end ones will be the connection ones. I mean, like just like to fit it onto the board, and everything else will be the connection joints, for the one for the plus and one for the minus. This is the DC bus bar. 700 amps. That's what we calculated that is supposed to be used to withstand actually. And yeah, that's the plan. Of course I will show it to you later on how it will be all mounted. I mean, you've seen it all. It was so quick. Like, I mean, literally, you cannot even do some kind of fancy music. Just like put it on the wall and that's it. Very quick, very easy. Anyways, a second day is finished. Guys are gone. All the bars, the holding bars, are sitting straight, exactly leveled as they should be. The cables are prepared, and all the lines are actually already in there. This one specifically is hiding over here, and we'll be later on going like this way before the finishing happens. Like, I will do this later this year. I plan like to actually make this looking nicer, but so far it's in here. And let me show you how the inverter zone is transformed already. So, okay, temporary. This is still old. The bus bar, the new inverter, and the cable come in. Where, I mean, this new DC line will actually fit in this box first. The protection box, the same one like I have here. Apparently nothing specific. But the bus bars, I wanted to show you. Oh, these are the beasts. Yeah, this is the main DC bus bar. Wow. I mean, wow. Anyways, so yeah, we'll just like wait a couple of days, and the cable is already in here, so the batteries will have to be put in here. So not much left, probably one more day, and we'll be launching it. Yeah, now that's the turn unpacking the panels, and you see, this is the very interesting moment. We'll let them lean a little bit, just a little bit, so they can stand still on their own, and just remove the first one. And now literally one by one you can take and either move or immediately set them up. So several of them will be put in the garage, they will wait for better times. And the others, 16X specifically, will be mounted today. Yeah, that's the plan, and that's the case. But I mean, this is how you generally undo the whole box of panels. Let's take a look how the panel is getting up. So some preps, you unzip tie the connectors. And then this kind of ropes with this kind of holders. Very easy, just using the just using the prefabric holes in the panel. That's it. Now it's ready. So let's see how it goes up. And there you go. So 3 of them are already there. This is the 4th one. 10 will be on that top, and 6 will be on the bottom part. 16 series total. 1 array, single array. Theoretical maximum open circuit voltage is 700 something, 730 I believe, in the very minus temperatures. I mean, that's the theoretical. Realistic one is like 40 volts for each panel, and like on 16, so calculated 640. Realistic working one will be, of course, less, because, well, once you apply some current, the voltage is less. That's again, natural thing. So yeah, there it sits, fits. Now it just has to be connected properly. And that's it. Let me show you everything else once it's done. Guys know what they are doing, because they are mounting these panels a lot. They don't have any breaks right now, like, I mean, they have the heavy load. The line is all over a month, literally. That's the case for the guys who are doing these kind of constructions these days in my country. A line for a month, so you have to wait to get your panels mounted. And that's how you want the business to be running, right? Whew, that was crazy. Put it inside, and I mean, it looks like if they had been living here all the time. Absolutely perfect fit. You can't even imagine, like, once you are like creating plans and etc., that this is the exact place for those batteries. I mean, literally, you cannot think of anything better. Like as if they are living here all the time, forever. Anyways, you see right now 75 kilowatt hours of storage. That's the half of my planned storage will be doubled, because the second part will be exactly here. And take a look, this is 25 kilowatt hours. And this one is 60. I mean, like 15 extra could be added, like, or here or there, like it will fit anyways. But still, like, the same space takes a 25 kilowatt hours set and 60 kilowatt hours set. Literally. What else do you need? I mean, these blocks are like fitting perfectly here. I have no words. So connection and launch, that's what is left. The last one for the top. I mean, it took some time for the guys to actually put them up. But I mean, well, it worked out. It worked out. And I'm amazed how actually optimal the surface is used.
Absolutely, almost fully. I mean, theoretically, there, like you can probably fit one more over there, but I mean that's already way too much because like 17 is too much for the line. So, anyways, so far I like it. It's done. I mean, the array is fully ready, and you may see like the angle is slightly different. But like, I mean, these like 2 degrees difference is not that big of an issue here. So I used them. I knew that, and well, still I decided to combine the in one array, all of them. Anyways, 3 working days for 3 people. That's what it takes to mount this 16 panels, almost 7 kilowatts of panels on this place. I mean, not the 8-hour working days, but like rather 6-hour working days, because well, once you're working over there on top, I mean, every hour counts as a little bit more than 1 hour. To those who know, those know. And the only thing that is left for me for later is to add 3 optimizers to this 3 end panels, because well, literally I just don't have them right now, but I will do this on my own later on. No big deals with that. It'll just have to wait a little bit until I have the instrument to do this finally. So yeah, that's it. And well, let's go and check how does it work inside. So I'll have to check the voltage now and everything else. Next day, 4th day of setting up the system. I'm waiting for my colleague electrician to actually do this stuff with helping me. But right now I am discharging my current battery pack. This is still Deye. Yesterday I was charging it to 100% and balancing the cells. And now I'm actually getting these prepared to be put on storage, temporary storage. I don't know what I will do. Maybe I might sell them, or I might use them elsewhere. I have places where I can do this. But anyways, I have to discharge them till 50. So that's what's happening right now. An hour and something, and it will get discharged fully until 50%. But before actually starting using this set of batteries, I have to do the following. Before there is any communication connected here, and this will be the CAN communication. So the first cable that goes from the BMS Ethernet terminal on the inverter, on the inverter. Let me show you where it is. It's somewhere here. Somewhere here it says BMS. You see this? That's the right one. This one. Right, but like, I mean, you have to do this from the master, and master will be that one. So from master the cable should go all the way here into CAN, and then from RS485-1 to whatever, and same down and to that one, so they will know that they work in a single pack. But I have to assign these addresses. And how to do this? You just use the documentation originally provided by Sepplus, nothing specific. If you have the CAN communication, do the CAN setup for 5 units in parallelism in my case, so I'm assigning the deep number 7 to be on. This means that this is the master, and there are 4 packs following after him. Because, well, pins 5, 6, 7, 8, these are the ones that you are assigning the for the main, for the master battery. Like this is a master one, and that how many next batteries does it have? I mean, if it's sitting like this literally means that there is only a single battery in the pack, and it's the only one, and the system will not know that there is anyone following. So I mean, it will work if you will connect, but it will use the charge and discharge currents for only one battery. In my case, I have to put the 7s up. This means that I told you like this is a master, and there are 4 after it. So the next one, which is the second, actually has to have the pin number 1 being up. Next you assign 1, 2, 3, 4. The second one is pin number 2. The third one is for pin number 1 and 2 both up. And the fourth one after the master one, the third pin should be up. So that's what I have here. And well, that's it. Basically, what else? Else you have we have to do to finish the connection, the data cables, and the AC cables because they are not connected yet still. As well as solar. Solar is actually connected, and I didn't measure some voltage. Voltage is absolutely good, so the system is okay, and some fuses. But I mean, we are missing the surge protection, so it will be added probably today as well, because like that has to sit there as well. For sure. And I mean, well, that will be it. Then we'll be mounting and setting this system to be used in parallel. Just wait a bit, and this will happen. Almost done. And actually, this is the main inverter that will be the master one. They are already paralleled. It's all working fine from parallel A going to that one to parallel B, and the BMS cable actually works absolutely perfectly. Already tested it. The only thing that I have to mention is about dips. I think I already told you this, that you have to clearly follow the instructions. Nothing, don't do anything differently, just like everything that is said to be done. The dip number 7 has to be up on the first one, then the one on this one. Like just follow the scheme. Like I mean, this is very clearly, Max clearly said. In the documentation, in the instructions, so you don't have to think about anything additional. Just like do what they say, and that's it. It will work out. It will show the whole battery. I mean, it works perfectly. And then once they are synchronized, even through the SAP to SAP, I can check. I see only one after that. After they are all paralleled, I mean, after they communicate with each other, I see only one of them, and it considers as the whole pack, and I can then check each of them without any troubles. Like easily, no issues with that. But one more thing I wanted to show you, like literally, once you are paralleling two inverters of like this kind of this kind, this is the 3-phase 10 kilowatt inverter. In my case, we have to additionally add the current trackers ultimately, because, well, if no current trackers, this one uses, the master one uses its internal current trackers. And since they are paralleled from here, from the input, so parallel goes here and goes to there. How does that one know what is the real power consumption? Where should it take from? So we have to add the current tracker. So the main input now gets into this kind of clamps. Let me call it clamps. It goes inside. Then we will make a loop. For example, here where the current tracker will sit, and then we'll go further back to the entry that was used before, to the input that was used before, and same for all three, just the phases. You don't have to do this for zeros or for PE bars or for neutral bars. You don't have to do this. Just like the phases. The phases have to be used using the current trackers, because, well, the system has to have the unique and single place knowing what's going on with the network, with the grid, and what specifically is your consumption and where from does it take. So let me remind you, I've been showing this on the inverter review, but these are the current trackers, and it has a tiny arrow. You may see it here. The arrow should be pointing in direction from your input to the inverters. So that's how we will be mounting them. But just bear in mind that since these are not Deye specific manufacturers, this is some different manufacturer for this kind of devices, and they are supplied like literally in same stuff for many other applications, for many inverters, for smart meters, etc. Like they are absolutely separate. This is absolutely separate product. Sometimes, in rare cases, that's what installers told me, it might be the case that this arrow is showing the wrong direction itself. So always like check using the first impression. So as I told you, to the inverter. But then if you see that the reading is wrong, just change it so you can see your reading properly. So we are almost done, and once done, I will do the launch and we will see what's going on.
And well, I can't show you what it's done because literally I've shown you this in the previous video, which you have already seen that the system is working and is working already for a couple of days. It works so far nicely. I can't say I'm that crazy happy, but I can't say that I'm unhappy. Well, because, well, if you know what you're expecting to have, you expect what to have, you get what you expect, then like it's like a natural state of things, you know. Uh, I have to check and watch on the system's behavior for some time before telling you if it actually fully matches the specification. So I'm taking a pause here. Just ask me in a month or two, how does it behave in like its full? Because like first of all, we have the faulty gen port, right? We have to resolve it. I don't know how long will it take because literally right now it's the 1st of February once I'm recording this piece of video, and the trouble is that it's Chinese New Year, so they have to get out of the holidays, and then we will contact the service center again, and we'll like follow the instructions with the resolutions. I assume it has to be dismounted and sent to the service center, and then come back. Probably the inverter replacement, probably some parts replacement, probably box like internal some board replacement, probably just release replacement. I don't know. This is up to them to decide. And I don't care literally whether it will be warranty issue or not. Like that lets them decide it. I need this fixed. That's it. Because I need the gen port to be working for my applications, and that's it. So that has to be fixed ultimately without like any questions. Who's paying for it? I mean, I would like it to be a warranty issue, but if not, I still need it fixed anyways. So, what else? Ask me again in a month or two, how does the batteries behave? I mean, I don't know yet in parallel mode if I will have all those same functionalities and functions because the inverters got the upgrade, they got the new firmware a day literally in a day that the system was paralleled to inverters together. So I don't know yet if it will have the same functionalities or if it's not. I will have to check it, prove it, and then let you know. But so far, so good. My plans for future is since I have that my DIY solar station that is having 11 panels right now, and I have exactly 5 spare. So this makes them 16 in total, and I was planning them to use two parallel 8 and 8 and to use in that of grid garage system. But now, since I have 16 here on my eastern piece of roof, and there it will be again 16 panels. Why not to make them parallel and put inside the PV1 of my second Deye? That will match, almost match both inverters in solar capacity. The second one will be still a little lower, 1.3 kilowatts lower in solar, but it will have a wind turbine in a couple of months added to it. So they will be, I would say, even equal. And that is probably a good thing to have once you're having a parallel system. I don't know yet. Again, I will have to check. This is everything all new to me. I don't know. Maybe some of you have got many. Some of you might have inverters in parallel, and you will tell me how it will work if they have different solar, for example. But what I have seen right now for almost a week of using the system, that sometimes the master inverter tells the other one to use not the equal power, but lower, significantly lower, depending on the solar coming in. That's what I have noticed. I don't know if that's the case and if that's the realistic issue, but I have seen that. So, for example, if we have a cloudy day with a little bit of sunlight shining here and there, but not the full sun, and one inverter goes on 2.53 kilowatts of solar and the other one goes at 1, because like I mean it's Eastern facing, right? So the issue is the panels are not in the optimal position. That's why they are producing a little bit less. They produce more in the morning, but in the midday, no, they won't. It's natural. And I have seen that the inverter kind of proportionally splits the load as well. So if the total load is 3 kilowatts, it will give 2 kilowatts on the first one and 1 kilowatt on the second one. I assume, that's my guess, I don't know yet, that might be because of this difference in solar capacity and solar input and solar energy actually coming in, not the input itself, but what gets into also might matter. I don't know. I can do a quick test. I can actually switch one of the strings from the first to second to see if it works. I don't know. Probably I can do this next month, or maybe I will just like quicker add 5 panels to that my other string. So to have the second array added, that might also be the quick option. But let's just wait and see. I have not decided yet which way to go for proofs. Anyways, thanks for watching. I've given you a lot of links, a lot of suggestions. Where did I get the components for my system? In the description, you will find them. Uh, these measures, the panels, of course, you have to get them locally. I mean, the inverter you can get anywhere locally, or you can get them on Alibaba. In my case, in Ukraine, for example, right now it's even cheaper to get the inverter locally than to buy it and export it from China. It might be even like $100 more if you get it from China, from Chinese supplier directly. That's a weird and crazy case, but I mean, well, if it is, it is, and you just have to choose whichever suits you specifically best. Um, Anyways, let me know if you have any questions. Hit the thumbs up, subscribe if you haven't still, and see you later. We'll have a lot of stuff going on later on, so we have to do a lot of things with the wind turbine still. Yeah. Thanks. See you. Bye.